So let's talk about the basic idea of I/O in Java and how it kind of works. So the way to think about I/O in Java is streams, and streams are really a good way to visualize them is a pipe. And a stream is basically just some way that data can flow. You can have a stream that flows data into your program or a stream that flows data out of your program. So you basically can have input or output. And these pipes that carry data that are called streams, they basically can be of different types. So one stream, just like a pipe might carry something different, a stream might carry some characters or a character string, or a stream might carry bytes. A stream might be connected to different data sources. You might have a stream that's connected to a database or a file or a network, and they could be implemented in different protocols. But the basic idea is this kind of abstract concept of a stream or a pipe that allows you to read from an input stream or write to an output stream. And so having that basic understanding of streams in Java is kind of essential to understand how I/O works, because I/O is based off of this concept of streams. So one way that streams are implemented in Java is basically through a pattern called the decorator pattern. And the decorator pattern itself is a little bit more complicated than what we're going to get into in this module, but we're going to use it, and even though we're not going to cover it completely. A really simple way to think about the decorator pattern, though, is, as you can see here, I have a picture of some Russian dolls. And if you're familiar with these Russian dolls, basically what it is it's a bigger doll, and when you open up that doll, there's a smaller doll inside, and when you open up that one, it's got a smaller one inside, and so on and so forth. And that's kind of how file I/O, or I/O in general, works in Java. And what it does is it basically wraps each layer. So you might have multiple streams that are wrapped in other streams. Another way to think about this is if you've ever taken apart, for example, a cable wire for cable in your home cable system, you'll notice that there's different wires that are wrapped in another layer. There's basically different coatings. There's kind of wires within wires. And so that's kind of the idea here, is that in Java, a lot of these streams are built up of other streams. So they wrap another stream, and that's using the decorator pattern. And this kind of complicates things, but it also simplifies things. And it complicates things because it's something that you might not be used to. It doesn't really present itself in the way that you think about streams and you think about file I/O. You might want to just open up a file and read. But it also simplifies things, because without this kind of decorator pattern, you would have this problem of needing all different kinds of streams to do different things. A good example here would be you basically can have a stream in Java that can zip or compress data that is going to be written to a file, or uncompress it when it's read out. And you could have a stream that writes bytes, or one that writes characters. And so if you didn't have this ability to wrap the stream that is able to compress over the stream that's able to write characters or bytes, you'd need a compression stream that writes characters, a compression stream that writes bytes, and all the different variations. What about if it's buffered or unbuffered data, and if you want to read from different data sources? So basically the decorator pattern makes it so you don't have to worry about each attribute of reading from a stream. It allows you to combine them together and make up the stream that you want from the streams that compose the outermost stream. And we'll start to see this as we get into the code. So let's take a look at what the basic hierarchy of the I/O in Java is. And this isn't all of the classes that exist in I/O, but this is how it's basically laid out. You have object at the top, and then from object, you have two sides here. On the left side, you can see I have input stream and output stream, and these are byte level streams. And the input stream obviously is in, and the output stream is out. But a lot of other streams inherit from either input stream or output stream, and all of these streams are able to write bytes. What I mean by bytes is raw data, not characters, not necessarily characters. It could be characters, but it could be just raw binary data. On the other side, you have a reader and writer. And these are text-based streams. These are designed to read ASCII characters. These are designed to read character sets and to read basically strings or characters in and out from whatever the stream is, whether it be a file or network or whatever it is, but these are character-based. So all of the streams and the readers and writers in Java inherit from one of these, either from the input stream or the output stream, or the reader or the writer, and they can be combined together. And all of these classes here are abstract classes, meaning that you can't implement them directly. You have to extend them, and the Java streams extend input stream, output stream, reader, and writer in order to actually create a real implementation of the different kinds of specialized streams that exist in Java.